Well, thank you very much, Heather, for that introduction. And I also want to thank you all for the opportunity to come here. It's actually exciting to me to be able to come and talk to a group of individuals that are actually very excited about hops and hop growing and getting a new, if you will, a new industry going in an area that it used to have a history of it. And Adam, that was a wonderful talk. I mean, just exciting for me to hear those things. I'm not a historian, but I love history. And you'll see I've got some of the pictures from history that I have in my office that I inherited from my predecessors who were here. So as it says, my name is John Henning. I'm actually with the United States Department of Agriculture, Agricultural Research Service. I'm also on faculty at Oregon State University as a geneticist there. And we're here at the Winter's Hops Conference, and this is a beautiful area. Next slide, please. So I wanted to, as I said, thank University of Vermont Extension for asking me to come out and flying me out here. And the little snafu that was spoken about was that I'm the type of person, unless it says distinctly, please call me when you come in, I'll just be like, okay, well, I'll go wherever I need to go and do whatever I need to do, and I won't bother anyone unless there's a mistake or something. So Heather was apparently having a heart attack, and I was just having the greatest time of my life here last night, just enjoying everything. So anyways, I want to thank the members of the USDA-ARS hop team. I have a molecular biologist named Dan Moore, who is what we call Computer Dan. He just does everything he needs to do, and he just gets it done. I've had several student employees over the year, currently just Chris Judy and Mary Stoner. And I have a new graduate student coming, Megan Toomey, and hopefully she'll be starting in a month or two. Sean Townsend used to be my postdoc, but now he's established himself as an Oregon State University faculty member working in hops and hop breeding too. David Gent is the USDA-ARS hop pathologist. And Paul Matthews, who said he was going to try and make it here, but I don't think he's made it here yet, from SS Steiner, is a collaborator with industry that I work closely with. Jason Peralt was here last year, and I worked with Jason quite a bit too. So next slide. Just as an overview, what I want to talk about is sort of the history and early production. And you've heard some of this already, but I'm going to go a little bit further back than what was covered by Adam. And then we're going to be looking at moving into the 21st century, comparing tall trellis versus short trellis, sort of the, the odds and ends of both of them, and how to do production of conventional hop varieties on low trellis. Then we'll be looking at the production of dwarf varieties on low trellis. And I'll cover sort of what we're doing with the dwarf breeding program that has now been initiated at USDA, and just briefly cover some of the low trellis designs and summarize everything. Okay, so what we're going to be looking at is just sort of how hops arose, where it went from, and everything like that. And so next slide, please. So actually the center of origin for hops is the Inner Mongolia area, and from that point then, next slide, it traveled in sort of two different directions. It was carried over by the early people who migrated from China and Asia over into Alaska and eventually into the sort of southwest area of the United States, and also in moving over towards Missouri and up into Manitoba actually as well. And that's an important point for my next talk. And from that point, it went over, that's okay, it's okay, I can handle it. It also went the other direction where it ended up carried over by, we're probably pretty sure, the Mongolians when they attacked and sort of Genghis Khan and that sort of realm that went into the European area and sort of settled in the Central Europe. From that point, a lot of, if you will, breeding and sort of early work that happened in hops was done there. A lot of the early use of hops prior to the 750s was used as a medicinal. Evidence that suggests that it was used in brewing at least 3,000 years ago. much of the early use of hop was that they just gathered it out in the wild and used it for brewing or for medicinal purposes. And the first recorded hop yard that existed in Central Europe was about 750 AD. A lot of the early hop varieties that we know now as the noble hops, people sort of went out and noted a special hop from a wild area, and they finally brought them into hop yards and they started growing them there. And they were spread, a lot of them were spread by cuttings, and so the land races that we know of now as the noble hops, such as your Satzer from the Czech Republic, the Tettnangs from, of course, near the Switzerland, the Tettnang region, and then Hallertauer are basically derived from these early land races that growers through the years just kept selecting the better plants, and then they moved to another farm and so on, and that's how it spread. So next. A lot of the hops that were grown initially were grown on tall poles. At the end of the years, the poles would be just dropped and people would pick the hops directly off of those poles. All of it was done by hand, and so I don't know if any of you here have done any hand picking of hops, but it's not a lot of fun. I did one experiment where we were looking at making crosses between very closely related male and female hops and very divergent male and female hops. And from those offspring, we then looked at, can the genetic diversity be a predictor of the parental success? Well, as you can imagine, any of the crosses that were made by that were made by crosses, but male and females that are very similar to one another, had a lot of inbreeding. And so I couldn't get enough hop off of those to put through my picker, and we all ended up doing hand picking of those for 2 years, and we vowed that this would never happen again. So anyways, during the early era of hop picking, there was a large influx, as Adam already mentioned, from the cities. People would go out and work in the hop yards, and also immigrant labor would do that. And when I first started in Corvallis, there was a number of old people that I would meet just talking. And these people actually went out and did hop picking when they were little kids. And so they would tell me about Adam said it's romanticized, and in some ways it was, because it was a very social event. But it was a lot of hard work, too, at the same time. And so they just did it, and that was part of life. So hop production then eventually moved to a trellis rather than poles. And during the early 1900s, they sort of experimented with low and high trellis designs. And they had, by the 1930s, they had both stationary and mechanical pickers. Some of the early low trellis designs, you can see some of this here where you've got I think it's about a 10-foot pole, and plants were on a 7x7 spacing, but what would happen is that the plants would grow to the top of that trellis and be allowed to grow over to the sides. Here's an example of sort of a tall trellis where they were looking at more of the 18-foot or 16-foot designs. Next. And some of the early mechanization that they had back around the 1930s and 40s, they had self-propelled or towed conventional pickers. Some of the self-propelled and towed low trellis pickers were designed in the 80s and early 90s. And the hops that were grown on low trellis at that time were all the conventional hops, sort of what you're familiar with doing here. And most of the efforts in growing the hops on a low trellis back in the 90s were eventually abandoned simply because the economics were not there in comparison to the tall trellis.
1890s or 1990s?
I'm sorry, 1990s. Did I put 1890s
No,
here?
but I just...
Yeah, that's kind of confusing. So yeah, this is the 1980s and 1990s. And it was eventually abandoned in the Pacific Northwest. I think there's still regions in other parts of the USA where they were trying to make a go of it. Next slide. And here's sort of an early example of a low trellis hop picker, and I think this one's developed by a farmer by the name of Desiree. And basically, this was on a 6-foot design, and it was one that was an advancement in that it had wheels that could go hydraulically lift up and go down depending upon the terrain that they were working with. Moving into the 21st century, now we're going up near the 2000s here. The first commercial dwarf hop variety called First Gold was released in 1997 by Y College in Great Britain. And this sort of revived a new interest in growing low trellis hops even in the United States. So why were folks interested in low trellis? We'll cover a little bit of that, and then sort of the new studies that are being doing to look at conventional hops. So, next. So if we want to look at growing hops in a tall trellis, we start out with spring labor and mechanical activities, or the land preparation, spraying the cover crops out. We typically try to have a cover crop to overwinter in Oregon because of the rains. Particularly since we're near a river too, the tendency is to sort of wash out all the soil if we don't have a cover crop. And so we try and do that. So we have to spray that out every year. Then we have what we call a pruning, where we try and cut back all of the new growth that comes up. A lot of the new growth, at least in the Pacific Northwest, is the harbor for downy mildew and powdery mildew that's been there from the overwintering. And so the idea is if you can spray it out at the beginning of the year, using a desiccant, or actually go through and mechanically trim it back down to the ground, that'll get rid of a lot of the inoculum for downy and powdery mildews. So that's one of the situations or things that we do. Then we go out and we do our stringing, and we train those plants. And then again, we're back to spraying. And then early summer, we do a method called arching. And I don't know if you're already familiar with that. It's basically tying the 2 strings or more together so that you can get your tractors through once those hops are quite up tall. Irrigation, cultivation, spraying, midsummer, irrigation, cultivation and spraying, and then of course harvest time. Next slide. When you grow hops in a low trellis, what you're basically removing is that you don't have to do all of the pruning of the established yard. Typically, you can spray that out as opposed to mechanically pruning. And in fact, you don't want to trim back or do mechanical pruning because you want to leave the hop growth that was from the previous season to allow the plants to grow back as opposed to having to go back out there and retrain again. You don't have to do any stringing. You don't have to do any training, and you don't have to do any arching. And all of these sort of methods or methodologies are very labor intensive. They're very expensive to do because labor is not cheap. And so that's sort of the interest in moving towards a low trellis design. Next. So some of the new studies on low trellis hop production, or how to trick a conventional hop into thinking it's a dwarf. So let's go for the next slide. Okay, I'm going to cover some plant physiology here, and I'm going to try and make it so that I can understand it too. Basically, the top growth point of a plant is called the apical meristem. And this apical meristem is sort of the brain, if you will, of the plant. The apical meristem makes a lot of the plant hormones that control what happens in the plant during the growth season. These hormones stimulate the stem elongation. That's what's called the growing of the hop. I don't know if many of you are familiar with this, but hop at its fastest growth rate can grow up to 6 inches in a single day. And I'm convinced that when they talk about Jack and the beanstalk, I think that was really a hop plant. I don't think it was a bean plant, because hops can outgrow beans by far. So the hormones that are made in the apical meristem also stimulate flowering. And one of the things that a number of studies have been done is that hop needs approximately 22 to 25 nodes, and that's where the branches come off of a hop, before flowering can be initiated. So it's sort of a dual action. There's a certain juvenile stage that has to be reached, and that's at about 22 to 25 nodes, as well as the onset of shortening days before flowering. So the onset of shortening days sort of stimulates the changes that occur in the apical meristem, and here we've got some sort of a picture from a paper by Shepard et al. In 2000. And if any of you are interested in nighttime reading to help you go to sleep, just ask me for the reference for this. So anyways, at the bottom you can see sort of a picture that this excited person took of the changes that occur in the apical meristem of a hop plant. And on the far, your left-hand side, we see a very broad apex, and then we see it shrinks as time goes on. And this is how what happens when that shrinking then happens. Then a lot of the GA, which is gibberellic acid, is reduced, and some of the other hormones, those are also reduced. And then what happens is the stem elongation slows down, and the lateral branches are then sort of told, okay, now we can grow. So that's what happens. The apical meristem slows down its activities, then the lateral branches will start, and that's where most of the hop flowers are produced, is on the lateral branches. So next slide, please. And in this same paper, they took the time to draw out all of these sort of diagrams as to where flowers occur. But anyways, you can actually trick a hop plant into thinking that it's time to start putting those lateral branches out fast. And the way that you do that is by trimming off the apical meristem. So we cut off the apical meristem almost as soon as it reaches the top of the trellis, and the lateral branches are going to start forming because you basically have cut off the source of the hormones to cause the stimulation of the stem elongation and inhibiting lateral formation. So with the onset of the shortening days after summer solstice, flower formation is then stimulated on these lateral branches. And you need as many lateral branches as possible. And so what you need to do is sort of really give the plant a lot of fertilization early on. You know, as much nitrogen as you can get to really get a strong flush of growth at the beginning of the season. And then once it gets to the top, of course you want to continue fertilizing, but taper off that fertilization. What that'll do then is it'll sort of also trick the plant into thinking, okay, well, now I've gotten all this growth done, now I'm going to start putting my efforts into flower formation.
So you're getting ready to, this was on a low trellis.
Yeah.
Did you do that same high amount of, so are you saying to kind of fertilize more so that you grow faster, more vigorously, because then you're going to chop its head off?
Yeah, for both low and high and tall trellis. You don't chop off the heads of the tall trellis, but this is with short trellis. But really the same factors are involved with the tall trellis. You really want to give it a good strong flush of growth. And then as the flowering season or as the summer progresses, you want to start tapering off on your nitrogen application, because what happens is the tendency is for the plant to just keep on growing more leaves and things like that. Plants will go into what they call a sort of a stress function when there's even a nitrogen lacking, and then that's what really puts out the flowers. If you keep on fertilizing all the way through the season, the tendency is to get a very, very flush, lots of leafy plant, but the flowers aren't going to be as strong. The hops, the cones aren't going to be as extensive. Does that help?
Yeah.
Okay.
I just didn't know if it was some strategy for low trellis.
It is for low trellis.
Okay.
So it is for low trellis, but it's also for tall trellis. And maybe it's more critical for low trellis because you really want to get that growth growing fast. And then once it gets to the top, you want to cut off the edges. Roy Farms and Jason Peralt, who you had here last year, did a study, or actually a funded study that the Washington small grants provided. And what they looked at was a series of different heights of the trellises, what was the optimum. And they also looked at sort of the spacing between the trellis, each trellis. And then they looked at sort of the spacing that went on within the trellis itself. And of course, this was all using a flexible mesh support. Next slide. And basically what they did is they grew a series of conventional hops, your regular hops that we all know, on the flexible mesh, which is about 6 to 8 inches in squares. The top support, of course, is a really strong steel cable, and then a bottom support need a strong wire. And the poles, they added, you want to add 3 feet to whatever height you're going to be using to make sure that the poles are really stable in the ground. In Y College, there was a study done in 1999, and this is a published study. Hops were planted at 45 inches apart, and they looked at using mesh versus string or twine. And they saw a slight edge in the yield using a mesh as opposed to the twine, and simply because the mesh allowed 100% hedge formation, whereas the string tended to have a little bit of opening within the hedge. And of course, we know that if you want to get a higher yield, you want that to be a solid, nice hedge production.
Is that plastic mesh or what?
It's plastic mesh, yes. And it's not just a regular old plastic mesh. I can't remember the type. It's a specialized mesh that
Made for low trellis hops, or is it used for other? I'm sure.
There's probably use for others, but it is. There's certain. I mean, I could get the name for where to purchase it from. Also, of course, the hop twine required more labor. They had to replace it every year. And of course, the flexible mesh was more stable. They did look at some wire mesh, and that was really a hard thing to work with. So if you're going to be getting into this, here's sort of an overall picture as to how much it costs to establish, let's say, an acre of low trellis. And basically, the bottom line is about $6,000 per acre. That's a little bit cheaper than what it costs for a tall trellis. So that's another sort of benefit that occurs from it. We found where in Oregon that it's cost about $7,000 per acre to establish an acre of tall trellis. And that's when you're looking at more than just a single acre. That's several acres.
Does that include labor for the construction of the yard?
No.
Okay. Well, it says labor on the bottom, but that looks like for planting.
Actually, no, that might be the labor. That is the labor. Yeah.
How much do people get paid in Oregon?
We're really cheap.
Nobody around here works that cheap, so I'm just...
Well, how's this?
I knew that was coming. John, your labor is not included there.
And it is and it isn't. And the reason it is because this was done on Leslie Roy's farm, this particular study. Leslie Roy farms 2,500 acres. And so for him, and he has all the equipment, he can put up I want to say 20 acres almost in a day. It's just phenomenal how much work they can get out of that. And so, yeah, when you look at the labor, that's probably half an hour. So yeah, basically take out the labor from that and then add it to the bottom line that goes there, and that's probably a more reasonable estimate.
Okay.
So yeah, we don't work that cheap. Okay. All right, so some of the hints for growing conventional hops and low trellis. The first year you are going to have to train the plants. Bottom line, there's no way of getting around it. We always joke about trying to breed for a self-training hop, and I just haven't had any success doing that one yet. But anyways, you do have to train the first year. You don't have to do that the next years because you leave the plant material on the trellis for the plant to grow up the next year. Get plants growing as fast as you can, early and timely nitrogen application. Once it gets to the top of the trellis, then of course you cut it back. And one thing I want to mention is we do what's called an early pruning. Now, this doesn't mean going through and cutting the plants down mechanically. What we do is we do desiccate these with AIM. Now, if you're trying to grow organically, I'm not sure what to do with that. I think somebody mentioned vinegar is being used. Is that right?
Yeah, probably could be.
Okay. Yeah. 20%. You could do that as a desiccant as well. But basically, and I'm not sure you guys would even be having the problem out here.
Yeah. Do you guys prune right away, Larry? Or? No.
Yeah. See, the reason for pruning in the Pacific Northwest is that downy mildew and powdery mildew are, of course, just absolutely prevalent there. And it overwinters, and so you want to cut everything off, or at least kill it off, any of the new growth that first comes up, because that's where all of the powdery mildew and downy mildew inoculum comes from. So that's why we typically do it. But you guys probably be able to get away with it until everybody's been growing hops for several years and powdery mildew comes back. And then you do have to worry about it as a problem. So,
how do they cut the top off? Like, what are they using to do that?
Hedge trimmers.
Oh, so by hand, though.
Yeah. Yeah, and particularly a lot of the organic growers just do it that way. They come through and they just go, get a hedge trimmer and trim off the top. And the reason for that is, I don't know if you can see it on this picture, but I couldn't find the picture I had. If you don't trim off that top, what you're going to end up with, at least in the Pacific Northwest, is this huge overflowing of growth that basically is all vegetative and maybe a little bit of hops. And so you don't get hops growing all up and down the trellis, it's just at the top. If you do the trimming, you tend to force the plant to want to grow hops all up and down the trellis. And so that's the reason for doing that.
And you do that, I'm sorry, I have a really bad listening thing. But when you said when the season starts to go the other direction.
Yeah.
Right.
Yeah. So you want to let the thing have a little bit of growth up at the top. But once things start moving in the other direction, then cut that off and really force the lateral growth to just take off. As I mentioned, after the harvest, leave the dry stems on the mesh, and then the next year the plant will self-train.
There's no disease issues with that?
It's all dead material, and so both powdery mildew and downy mildew are what's called obligate parasites. They can only grow on living material or survive on living material. Everything that's going to be left over there is going to be dead. So it's just sort of a little mesh to grow up.
I'm sorry, I can't quite see. Are there any cover crops in between the rows, or is it just left open?
Now, these particular ones did not have any cover crop in it, but I would, out here, I would suggest a cover crop. And particularly if you can get, like you were mentioning, a clover, I think that would be wonderful. There are some growers in the Pacific Northwest that swear against that simply because they say that it's a harbor, or it can be a harbor for a lot of moisture, and then that moisture stimulates the downy mildew and things like that. But if diseases aren't a problem, I'd say go for it. Get a nice little nitrogen producing crop down there in the middle.
Just mow it instead of going through the tractor. But anyways.
The different hops, conventional hops on low trellis versus tall trellis. And, I think my best advice that I can give to you is just try out the different varieties. Some of them are going to do well. Some of them are not going to do well. And you'll find that out really quickly. Willamette, which is an extremely popular hop in the Pacific Northwest, is probably the worst hop you can try to grow on a low trellis. But if we look at this slide here, the blue lines are the low trellis yields, and the red lines are the same hop varieties grown on tall trellis. And what you see...
Per vine, or what is that based on?
This is per acre. These are per acre estimates. And
Is that dry?
this is dried hop, yes. Yeah, I'm sorry, it's kind of hard to read over there, but I think that the highest yielding one, which is what's called the CTZ, or Columbus Tomahawk Zeus, is about 2,600 pounds, 2,700 pounds per acre of dried hop material on the tall trellis. Now, if we look at the low trellis, that drops by about 30%. Down to, I think it's 1,800 pounds per acre, thereabouts. So CTZ overall is just a very healthy plant. Now, I don't know how CTZ would work out here, because CTZ was developed and bred in Washington, and it does extremely well in very, very hot climates. It doesn't do as well in very cool, mild summers. So I'm not necessarily recommending that one for you to try out.
Is that a public variety, or?
It's a long story that ended up that, yes, you can get it as a public variety now, but it was actually 3 different companies that named the same variety different names, and then they ended up suing each other. And then they ended up all just agreeing to be kind and let everyone grow whatever they want to. And so it's now called CTZ, or Columbus Tomahawk Zeus.
It's like the 1800s.
Yeah, yeah. The hop industry is a very interesting one to work with. There's a lot of legal suits and things going on and accusations made, and what they call the, patent place type of a thing, whatever the name is. There's always this some conflict going on between grower or between merchants and between states, and it's pretty funny. So looking at some of the other varieties, though, that perhaps may do quite well is that of Nugget, Galena, and then Cascade. And I've already found out that you guys are trying Cascade here, so that one might do well. I saw that you guys are going to be trying to grow Newport, and I think Newport is going to do very well here. I bred that in Oregon, and that one does well in cooler climates. It doesn't do as well up in Washington, but it really enjoys the cooler climates.
That's your variety?
Yeah.
So that's why it's going to do well, or?
Of course. Don't tell me if it doesn't do well. But anyways, Newport probably would do well. Cascade, of course, would do well as well. That was another one that was developed in Oregon. And Willamette, I mean, you could try it, but growing on low trellis, I'm not sure how well it would do. It is developed in Oregon. My predecessor developed that one. And so you could try it. I don't know. That's my best suggestion, is to grow different varieties. I saw you had a large list of varieties, and that's excellent. That's the only way to figure out what's going to work, it's not going to work. The other suggestion that I would have is talk to the brewers. Talk to the brewers. If they don't like it, it's not going to sell. So the bottom line that I've learned over the years is you've got to be in communication with the brewers, and what they want you to grow, sometimes you just have to grow. Somebody mentioned Sterling wasn't doing that well. It's becoming a very popular variety with the brewers. So, you just try it out. It is a hard one to grow from cuttings, I can tell you that much. It doesn't do well from cuttings, but once it's established, it does fine. So it's just, might be a little bit of a problem. Other questions on this? Yes?
How long would you be willing to give a certain variety before you say to yourself, all right, I need to grow something else, and let's move this out here? Is it a 3-year window? Is it more?
3 to 4 years. You should be knowing. If it's not doing something by 3 years, it's probably not going to. If you see a slow trend upwards, then maybe it might be worth going until the 4th year. Your first year out in the vine, it's not going to do much of anything. Second year, we call it the baby year. You might get a little crop out of it. Your third year is sort of going to be the indicator. Yeah, this has got some potential. Then by the 4th year, it's going to be fully mature, and that's going to be your optimum. But if it's really just not doing anything by the 3rd year, we typically just throw it out from breeding perspective. Yes?
Low Trellis nitrogen application, I'm assuming you're using a row application, and are you also doing split nitrogen application?
We do. I personally do split nitrogen applications, but I'm growing on a tall trellis. So you may want to do, we typically say about 150 pounds of nitrogen per acre. You may want to do 100 in the first one and then come back with the 50 later in the season.
Is that based on applying per row, or is that a broadcast?
That's based upon per row. Basically, we calculate how much it's going to be, and we apply it that way. Other questions? Yes.
Is this, there's a similar trial that I just recently read about. Is this the same trial that actually tried different heights? There was a study I read about 8 foot, a 9.3, and then a 12 foot.
Yes, same study.
Okay. I was just curious on the harvesting, if you were you picking right off the row, and you had to basically, you weren't doing decapitation and processing at a satellite location. You had to actually do your processing right in the field.
Well, this study, as I mentioned, was done at Leslie Roy's farm, and so they actually had their own low trellis harvest machine. Actually, they've got 2 now. But anyways, they were cutting up. They found that they had to do the same thing. They have to cut off the tops, and they've got mechanical pruners that can go through and just chop it off. But they did find the same thing, and they found that the 8-foot trellis basically was the easier to use with the instrument, the equipment they had, and the yields were not significantly different between the 8 and the 9.3.
Right, I saw the reduction in the 12 foot.
Yeah.
It was interesting. Then I shot up to 18, it was like commercially viable.
Yeah, and then you look at the 18-foot and it does great. So go figure. Next slide. Oh, yes.
Is your harvest earlier because you're cutting the growth before they got that extra couple of weeks they do growth, or you have to even put down?
Nope. The hop plant harvests when it's ready, when it wants to. And some of you mentioned, well, how do you know when it's ripe for picking? And having to go out and look at 15,000 different seedlings a year and walk through, I've learned that it basically, I don't know if you've ever played with crepe paper before. Not that I do it on a regular basis now, but anyways, it's when you take the hop cone and pick it and just kind of squeeze it between your fingers right next to your ear. If it sounds really crinkly, it's ready to harvest. And that's just a basic line. I mean, that's going to get you around 22% moisture, which is what you want to get at. And the other way of doing it is doing dry matters. And of course, a lot of that's been published as well, so those are available. Your dry matters is the accurate way to estimate when it's ready to and optimum for harvesting. The other thing is that there are certain studies that are going on right now that are looking at when's the optimum time of harvest to get the highest level of alpha acid in your plant. And then also the highest level of oils that occur in a plant. So there's several studies that are going on right now. Tom Shellhammer at Oregon State University is pursuing some of these things. And so hopefully within the next couple of years we'll have an idea. Because, we say the optimum time of harvesting is at 22% moisture. Well, that's a general rule. For different varieties, it's different. And so if you talk to the Boston brewery people, they like to see their hops at a higher dry matter material than what other brewers like. And so it also is going to be dependent upon the brewer too. So it's not an easy question to work through, but general rule, 22% dry matter and you're ready to go. So what's the bottom line? Yields using conventional hops on low trellis are always lower than for a tall trellis. Yield loss ranges from 80% from tall trellis to low trellis, which is Willamette, to 26% loss, which was Cascade. It's highly dependent upon the variety, and that's, you should try it out. Highly dependent upon the environment, you should try it out. As a USDA representative, I get phone calls from all over the United States. And what I'm telling people is, they got a phone call from Alabama 2 days ago. Can I grow hops? I don't know. You got to try it out. You got to try it out. You're going to be my source of information. And so that's the best answer I can give.
In Vermont, we say it depends.
There you go. So then, looking now at dwarf hops on low trellis, this is a picture of the dwarf hop breeding facility at Y College in England, and that's Ron Beatson there. It's actually the hop breeder down in New Zealand. Next question, or next. So, dwarf hops, of course, are grown in the same sort of a trellis system. Dwarf hops do not need a trimming of the tops like the tall trellis or the conventional hops do. They have a lot shorter internodes, and so they have a greater sort of greater growth of the lower laterals early on in the season rather than later. They have significantly higher yields when grown on low trellis. Many of the dwarf varieties that are developed now have the same yields as conventional hops on tall trellis. So there's really no reason not to grow on a low trellis. And most of the English hop growing is now moving towards low trellis simply because labor is way too expensive there. There are no true dwarf hop varieties available in the United States. There are two groups that are licensed to have dwarf hops. That's the American Dwarf Hop Association and myself. So next slide, please. The English Hop Association has been very strong on trying to limit the movement of the dwarf hop varieties. And that's why you just can't get it. I mentioned the American dwarf hop varieties. They have a license to do First Gold, which is the first hop, the dwarf hop developed. My program then was able to obtain material from Pioneer, which was a little bit later developed hop, and which is more of an aroma hop rather than First Gold, which is a bittering hop. The beauty of that is that I happened to have some germplasm material that they really wanted, and I said, give me some of your dwarfs. And so we made this exchange, and that's how that came about. Next slide. The English Hop Association, yeah. They wanted, I don't know if you're familiar with a hop variety called Tea Maker that I released. It's zero alpha and high beta. And it's used in a lot of actual livestock feeding now as a replacement for antibiotics. And so that's what they're using it for. As I mentioned, the cross that they provided me was a cross between Pioneer and a male called 2595-15M, of which they wouldn't give me the pedigree yet, but I do have the DNA from it, so I'll figure that out. Okay, next. So just looking at the USDA-ARS dwarf breeding facility, right now I have a population of about 150 different offspring that came. Those are both male and females. And so this is the beginnings of the hop breeding program looking at dwarfs. And it's so interesting to look at a dwarf breeding nursery because you have a mixture of very tall hops and you have a mixture of very short hops and some even in between. And the thought is that it's a single gene that controls the whether or not it's going to be a dwarf hop or not. Also, it's thought that the homozygous nature, or basically if you had both dwarf genes from your male and your female parents, you're going to die. It's a lethal condition. So the only ones that are true dwarfs have the dwarf gene from one parent and the regular gene from the other parent. And so it's what's called heterozygous. And so anytime you make a cross onto a dwarf plant, the offspring from that cross are going to have both, you'll have both tall trellis hops and low trellis hops. And so it is somewhat easy to pick it out. So here you see sort of a picture of a low trellis on the left and a tall trellis on the right. But the interesting thing about it is that the dwarf plants, the true dwarf plants, have very short internodes. We're talking about 3 to 4 inches between nodes, as opposed to a regular hop plant having up to a foot between each node. And in addition, a lot of the lateral branches that form down at the base of the plant are very strong, and they're not as inhibited by the apical meristem as are the conventional hops. Next slide. We planted this seedling nursery out in 2009, and I looked at them for the first time this past summer. Approximately 60% of those are true dwarf plants. The rest are very tall plants. Some of the apical meristems actually stop growing to about 2/3 of the way up a regular hop trellis, and so it does have what we call a terminal bud at the apex. You'll have a little flower that actually forms up there, and that's it. It's not going to grow anymore. We collected seed off of each female dwarf, and each one of those seed collections represents sort of a new breeding line that will be looked at for various sort of breeding purposes. Next slide. And I just wanted to cover really quickly my recommendations, which, it's worth 2 cents, and really 2 cents isn't worth a lot right now. But anyways, there's many designs possible. We already saw the same picture here. The biggest thing is, use your imagination. If you're going to be growing a conventional hop plant, you want to give it as much growth as you possibly can. If you're going to be, focusing on a low trellis, then you are going to have to focus on cutting things down. If you want to keep things from cutting and just grow it along a lateral, you can do this bottom design down here and let the hops grow along lateral lines at the top. Your conventional hop likes to grow at about 18 feet to 20 feet. It's been bred to do that. And so the best designs don't force the plant to grow back down on itself, okay? Once you have a situation where the plant comes to the top and then grows back down, you have a situation where you're getting shading of the plant, the actual hop cones, and it just becomes very vegetative. So allow the plants to grow out to the side somehow, some way. And that's another reason for the sort of tent design, is that it kept the shading to a minimal that way. Okay, short trellis production summary. Reduced yields with conventional hops. Significant labor reductions and cost. I mentioned that the labor savings can be up to 60% from low trellis to high trellis. It's a significant savings in labor. No stringing, no training, no arching. You also can get precise pesticide or spray applications, because with the 18-foot trellis, in a lot of cases you have to use an orchard boom blast, which, if you've ever seen one of these things, it's shooting pesticides and sprays 30 feet up in the air. And anytime you get up that high, you're going to have a potential for drift. So it's a very sort of environmentally safe way of growing hops, to grow them on low trellis. And also, you don't have to use as much spray, because if you're having to spray 30 feet up in the air, you're going to have to increase the amount of spray that you're putting out. Whereas if you're spraying just up to 8 feet tall, the amount of spraying can be applied directly to where you want it to go, and you don't have to use as much spray. And of course, if you're having to pick by hand, it's just a heck of a lot easier to reach up to 8 feet than it is to pull down a hop vine and pick it on the ground. So I think that's it. It is. Any questions? Yes?
Your questions, actually. Your spacing between your rows on the low trellis is approximately 8 foot.
In the tall trellis, we go with an 8-foot spacing. In the low trellis, you want to go about 45 inches between plant. Oh, between rows. That 8 feet was determined to be the optimum width because you were able to get more yield per acre that way, and the shading wasn't an issue.
And with reference to shading, are your rows oriented north to south or east to west?
Northwest, no, north-south. Yeah. I saw a question over here. Yes.
What's the minimum distance of separation between varieties to prevent cross-pollination?
Well, you're not going to get any cross-pollination unless you have males that are nearby, because all of the varieties are female. And so now if you're worried about the mixing of the hop cones during harvest, then I would suggest sort of a minimum between growth of about 8 feet. Between, if you're in the same row, 8 feet distance between the different varieties. Is that the question you wanted to answer? Okay, yes.
Is there any access to that PowerPoint presentation you just gave?
Sure, I can give this out, yeah.
You can also do it some of it?
Yeah, I think I might.
There's a handout in the back.
Oh, the handout?
Yeah.
is- I didn't see some of the slides in there.
Are they all?
They're all on there.
Yeah.
Oh, maybe, okay.
There's 2 handouts, so they look kind of hoppy, so you maybe only touch them.
Yes.
You mentioned variety teenager, is that available publicly?
Yes, it is.
Nowhere?
As a public servant, I'm not allowed to make any recommendations, but if you email me, I can probably give you something over the phone. But I'm not supposed to make anything. Now, the USDA-ARS has the germplasm repository in Corvallis, and you can obtain tea maker from them as well. But right now, there's a moratorium on delivery because of fears about what's called the hop stunt viroid, and I'll talk about that later. But it's causing a problem right now, but email me and I'll be able to give you more information. I think there's one over here.
You said there was a problem using metal mesh as opposed to plastic. Can you say what that was?
It's simply that the strain on the trellis itself was too much. The plastic mesh allowed sort of movement of the plant, the hedge to be able to move back and forth, whereas a metal hedge, the metal wet mesh, tended to keep the hop rows real, sturdy and stable. And in high winds, there was no give, and so the trellis, in some cases, fell over. So they had some. That's bad, yeah. And that's a bad thing. Yes.
Can you direct us any more research on the use of hops for antibiotics in livestock?
Yeah, there's actually a article that was written in 2004, and I could get you that reference, but it was looked at in poultry. And they found that this use of this tea maker was the infection rate in poultry hens was equal to that of antibiotics, and they found that brooding hens were happier.
How did they measure that?
I don't know. Yeah, but now there's also some studies going on looking at it in hogs as well as in beef. And really, if you think about it, the other thing I didn't mention is beta acid is the sort of antibacterial compound found in hops. They are now using it in sugar processing as an antimicrobial and in ethanol production. Because in ethanol production, you need some sort of antimicrobial as well. And so that's another area of use right now that they're looking at it.
Any studies on humans?
What's that?
Any studies on humans?
It's extremely safe on humans. I think so. Yes. Actually, I think there's a couple of questions in the back that I missed. Yes.
Any prediction on how many years the plastic and trellis system will last?
I've heard range of 8 to 10. Yeah, that's why I say it's not just your regular old plastic. It's a specialized plastic. That's what do they call it? Photoinsensitive or something like that.
I think it was a 4-inch mesh that they were utilizing for, that was, I read it off.
Okay.
I spoke with the Roy folks here about that netting. It's basically like a bird netting for the Jews. We use it around here.
Uh-huh.
So I mean, it's easy
Yeah, it's real durable, so. Okay, great. What's that?
Somebody called Farm Tech got that.
Excellent. Yes. I don't know who was first. I'll go with you.
Well, with the foot and mesh, does that change the way you harvest? I mean, you still use mechanical harvesting for that versus the twine?
You have to have what they call an overhead harvest machine. So it is a specific machine to it, or you do hand harvest. Yeah, so it's one or the other. What I would suggest is all of the Northeast get together and maybe buy. If you're really going to be going the low trellis route, is going together and buying one that can be used various places and shipped around. They're not cheap, I can tell you that much. More questions? Yes.
Well, I'm just going to say that I used to brew a tea for my kids out of hops when they had earaches and sore throat.
Oh, yeah.
And I give it to them for 5 or 6 days, and it used to work. I mean,
Yeah.
it's used medicinally, that's an old thing that you take. And also, one of that company does have that.
Yeah, well, I mean, that was the main purpose of using hops when they first started using in brewing, because they had to have some way of maintaining the ale, which the English actually called ale that didn't have hops in it before 1700s or 1600s. And so once they started hopping it, then they still called it ale. But the stuff that you used to drink back then was a real sweet mead. And the way you would keep it preserved was either juniper berries, or then they started using hops. People got acclimatized to the taste of hop in it. So it's an excellent antimicrobial. Yes?
I don't know if this is a good question for you, or maybe someone here would know, but does the USDA do alpha content testing or analysis on different, say, hops that I would grow? Is there a way to get that tested?
I used to. I used to have actually a chemistry lab, but the funding for that was slowly fading away, and it was ending up that I was using all of my research funds to keep it going. There is a possibility of getting it done by the Washington Department of Ag. They still do some testing. Oregon Department of Ag might do some testing as well. Basically, if you have a spectrophotometer somewhere in a university, you can do it there. It's a very easy extraction and reading technique.
I believe the Hops Union just opened a lab.
They did?
And
Okay.
it's $30 for a sample, and somebody already tell you that?
Yeah, you did.
Yeah,
Okay, cool.
They charge 30?
$30, yeah.
Oh man,
So
I
you
could
missed out
have.
on that.
I missed out on that.
You were too nice, you were calling it free.
Something
Well-
that universities would do though,
Well, I mean, it's a possibility, but the thing, is that we don't really want to start a testing lab and not be able to
Yeah.
carry it through over the long term. So it's something we thought about, but, we can't really commit to it at this time. So my suggestion would be to send it off to Hops Union. They're very fast, I've heard.
Yeah.
Very
Yeah.
professional. They sent me a bunch of literature and information on, working with their lab. They just got started, so, honestly, sometimes it's better for us to support one place so that at least something keeps going.
Yeah.
Versus trying to spread it all around. But maybe in the future, it's something we could think about at UVM.
2-ounce sample they want, you said?
I'm not sure exactly what it is. Yeah.
At least 600 grams, I can tell you that much. So that's the minimum amount you can do an alpha acid on. Other questions? Yes.
With respect to DNA testing, we had what we call it classified as a heterogen but it's been around for years. So you do DNA testing to find out what the actual variety is, so that we could reference it for future brewing, and if so, how much it would be?
Yeah, I don't do the variety testing. As I mentioned, I get phone calls from all over the USA, and I get a large number of calls from people who want me to test, this variety, and it isn't a simple thing, because I would have to develop DNA fingerprints for all of the varieties to be able to do that, and I don't have the resources to pursue that. My hope is that by me sort of doing all this work, there will be some other labs that will come along, and then they'll start doing it for a service. But USDA-ARS isn't a service lab, or it's a research arm. There's this question in the back there. Yes, hiding back there.
Do you have any idea the timeline of when dwarf varieties will be available commercially?
I don't think I can get anything out for at least 8 years. There's a possibility I could accelerate that, but the danger in accelerating things is getting a variety out that we find out later on that has some problems that we didn't see ahead of time, and then then that hurts the grower. So we want to make sure that we have everything pretty much figured out before we release it to the growers. But everything that the USDA does, for the most part, is not patented, and so it becomes public and publicly available. Other questions? I think, yes.
And how about doing cuttings of the varieties? Can you do your own cuttings, like a licensed variety, or how does that?
Do I? Is that what you?
You can get a variety. I do like my own cuttings. Can you do your own cuttings?
Oh yeah, yeah. You can do your own cuttings. About now, or even a little. Well, here in Vermont, it's different. Maybe in March, you can go out, and what I suggest if you're going to want to make cuttings on a plant is we do what we call hilling, where you get a lot of the soil up around the base of the plant, and what that does is tends to stimulate the lateral branches that are at the base to form rhizomes that will be available for the next year. Other questions? Yes.
Is the water requirement for dwarf what's been,
Good question. I don't know the answer to that.
What was the question, John?
The question was, is the water requirement for a dwarf hop different from a tall trellis hop? And gut feeling is that maybe it might be a little less, but I wouldn't go out and try and starve your hop right yet. Better to give it a lot of water and keep it growing as fast as it can and keep it happy.
So I think you're going to be around, so you can
Yeah.
corner John at lunchtime. I'm going to take your microphone back. Thank everybody,